Okay, we're going to talk about complex numbers. Now, a key concept in algebra is that the roots of polynomials are going to actually have a lot of complex numbers involved. But first, we need to define complex numbers. So complex numbers are going to be understood as having a real component, that is A plus BI. So this is the standard way of writing it. A and B are going to be our real numbers, okay? Okay, A and B are real numbers. And so BI is going to be your complex component, or your imaginary number. So BI is imaginary. And A is going to be real, okay? The real component. Okay, so this is complex numbers. Now, equality with complex numbers. I'm not gonna blow this up, I'm just gonna write underneath it. So, actually let's blow this up, that will make it easier. Okay, two complex numbers, A plus BI and C plus DI, written in standard form, are equal to each other. So that means that A plus BI equals C plus DI. This is if and only if A equals C and B equals D. Okay? This is only true that these two are equal to each other if A equals C and B equals D. Okay? Now we're going to look at some operations. Okay, so we're going to look at addition. So addition, summary of that, without any hubbub, is going to be it's going to be A plus BI plus C plus DI. So this is two different numbers. It's going to equal A plus C plus B plus DI. Okay, that's going to be addition. And just like addition, difference is going to be, difference is going to be A plus BI minus C plus DI, and that's just going to equal the A minus C plus B minus DI. Okay, so the effects essentially that combine like terms. Okay, you're treating I kind of like it's that it's separated from the numbers. Okay. Now we'll talk about multiplication in a second. Actually, we could just write it. So multiplication. Now there's several ways of multiplying. So we're just going to simplify it. If you have if A plus BI and C plus DI, what's going to happen is you're going to get A times C plus DI plus B times BI times C plus di. Okay. In the end, this is going to actually equal, by just sheer math, you're going to get AC minus BD plus AD plus BC I. Okay? So this is going to be multiplication, okay? This is the simplest form. Okay, we can look at practice problems in a moment. We're going to look at practice problems 1 through 3 on our paper. But let's talk about complex conjugates. So complex conjugates are written such that you're going to have A plus BI times A minus BI. So the difference is the complex portion becomes negative. This is going to give us A squared plus B squared. So what does complex conjugates give us? They give us real numbers, okay? Okay, that's a way of getting real numbers, okay? So division is going to follow this. Division is going to require us, we want to remove make the denominator a real number by multiplying by the complex conjugate. Okay? Make the denominators DEN, OMINATOR. Okay, make the denominator real by multiplying by the complex conjugate. Okay, and we'll look at some examples for this, and then we'll talk finally about principal square root. Okay, so examples. We're actually going to shrink this down. Sorry, not that. Okay. Okay. Let's do some practice problems. And hopefully finish in time. It's always possible. Okay. Addition. I'm just going to go through this pretty quick. So if you have a question, you can always ask me in class. Okay, if we're adding this, we add the real numbers, so we get 5. Add the imaginary, we get plus I. Okay, subtraction. If we did 1 plus 2i minus 4 plus 2i, we subtract, so we get negative 3. Subtract, we get nothing, so this is our answer. Multiplication. 2 minus I is 4 plus 3i. Now the way I do it is I use FOIL, but you can use whatever method. So I do 2 times 4, which gives us 8, plus 2 times 3, which gives us 6i, negative I times 4, which is negative 4i, and then negative I times 3, which is positive 3. It would have been negative 3i squared, which becomes positive 3. Okay, 8 plus 3 is 11. 6 minus 4 is 2, so plus 2i. Is that our answer? Yes. Okay, so that would be our answer. So doing multiplication. You could also try doing it a simpler way with multiplication. And if you have it squared, obviously you just multiply the same thing. We'll just do a lot of practice with this, okay? Okay, let's go to division. So if you had 2, actually, what's the complex conjugate of 1 plus 2i? This is 1 plus 2i, then 1 minus 2i. If you multiply this together, you get 1 minus 2i plus 2i minus 4i squared. This becomes 1, these cancel, This would become plus 4. So our answer would be 5. Okay? That's how we find the complex conjugate and check it. Okay? Okay, if you are dividing by a complex number, this trips a lot of people up. You want to first multiply by the complex conjugate, both top and bottom. So the top would become 8. Sorry. Would become 8 plus 4i plus 12i plus 6i squared. Bottom would be 16 plus 8i minus 8i minus 8i squared. 8i squared is going to become positive. This is going to become negative. So this will be 8 plus 4 plus 12 is 16, so 16i, and then minus 6. Bottom is this 16. The plus 8i minus 8i cancel, so you get plus 8. Combine like terms, you get 2 plus 16i over 24. Can you simplify this? Yes, you could divide by 2. So you get 1 plus 8i over 12. And that would be our answer. Okay? Wait, sorry. It should be 4. Oh, yeah, that should be 4. My apologies. So this is 2i times 2i. That should be 4. So that's 4. So this is 20. This would be 10. Okay. Yeah, and so the way the book does it is it separates this. So this is 110 plus, and then 8 divided by 10 is 4 over 5. It's 4 over 5i. So this is the way the book does it. Okay. Principal roots, square root. We're almost done, people. Real quick, principal square root just means this. Simplified. Okay, if you have the square root, okay, of negative a, okay, that will equal square root of a times I. Okay, and then we'll talk about finding complex solutions to quadratics. Okay, that is it. Oh, sorry, my apologies. This is a little bit out of the picture. There you go. You can pause the video and check. Okay, thank you guys so much. My apologies for this longer video, but we'll talk more about complex numbers in class. Okay, bye.